So I'm going to talk about auto research with the search underlined. I think this is a hot topic that everyone's thinking about these days. It seems to come up a lot in my consulting, and colleagues tell me it comes up in their consulting as well. Those people who don't know me, my name is Doug. I'm Dougie in a Snuggie. That's me. I've written a couple books, AI-powered search, relevant search, with some different great folks. I'd love to learn about search. I'm still trying to figure out how it works. That's kind of what I've been working in search since 2012. I'm still trying to figure that out. I like embarrassing myself as a service, and I do that through consulting and training. There's many of my students here at the class. I appreciate you all coming and saying hi. And yeah, I've gotten to work at search a lot of different places. I probably have a whole search management talk from Shopify that would be interesting at some other point, maybe as a session. As I mentioned, I do training. Trey had to step out for a bit, but he'll be back. Trey and I teach a course based on the book we helped write, AI-powered search. AI-powered search is really just a great overview of, I would say, all the retrieval topics that are relevant to teams that we work with. So anything from learning to rank to agentic search to RAG. It's a very broad-based course over the entire month of July that we teach gradually. There's a discount code there, Berlin, $450, and the discounts only get lower as time goes on, so this is the best you'll do for a while. Definitely check it out. We have a lot of fun teaching the class. We're also going to offer, if you sign up for the Women of Search newsletter, a scholarship to someone who signed up. So also do that as well. So that's another opportunity if you want to come for free. So with that, I'm going to talk today about auto research. So auto research, of course, this idea that came out from Karpathy. Karpathy tweets something, and then it becomes the thing people talk about for like 3 weeks or months or years. But the basic idea is we just have a more or less a numerical objective or some kind of objective, and we have a coding agent trying to problem solve until that objective is met, or to optimize or hill climb that objective. And of course, this applies to search as well. And one reason you would do this as opposed to regular model development, you can use auto research for model development, is you already have something usually deployed in production and you're just optimizing it. You're making it a little bit better. So people often talk about, I think the most frequent cases, I used /goal in a lot of the coding agents, and I improved latency by some amount or something. I reduced how long a request took for my web server or something like this. So that's very common. So I'm going to talk today about my exploration of experiments, mostly in e-commerce, of doing auto research. You'll see that I'm a trainer. I'm also someone who looks at code, even though we're not supposed to look at code anymore. I'm going to persist in looking at code, even when the AI agent generates it for me. This is my own setup that I do, and I do a lot of experimentation with this, in part so I can work better with clients and teach better. And I think what you'll see in this graph, like who's under the mask, auto research. If you've done machine learning, a lot of the lessons of auto research are the lessons from machine learning. And that's a common theme that you're going to see today. I have a repo that I do all my search experiments in, but in particular, if you want the notebook for this, feel free to get a picture of that QR code. I'm going to count down from 5, 4, 3, 2, 1. Okay. Yeah. Yes. No, it's only available, and it's just self-destructed. So my agentic search setup. So I'm going to talk a little bit about agentic search, and then I'm going to talk about auto research. So agentic search, the general idea for those who don't know, is this notion that we have this tool calling loop, and all it's doing is maybe interacting with the environment, given a prompt, and trying to find the things using the tools available to it. So an agent, of course, is just an LLM that produces tool calls, and we pre-perform those tool calls and we return results back, and the agent decides, oh, this is relevant to this problem or this is not relevant. Agentic is just really agents solving a search problem for us. So you'll see things these days like oh, I don't need any search engines anymore. I just give an agent grep and all of my problems are solved. And this is maybe true for small amounts of data on your file system on a knowledge base kind of search. So you hear these kinds of stories these days out there on Twitter and X, where X is like the crazy AI hype machine these days. So you see all the crazy ideas if you're on there. So what this actually looks like, if you did agentic search, there's your boring old hallucinating AI. This is some blog post that I did not write. And like I said, I'm going to show some Python code. Here's the Python code of just setting a prompt to OpenAI and getting some response back. And those sound like great blog posts. I never wrote a blog for Elastic called BM25 Explained. Sounds great. They seem like things I would write, but I didn't actually write these. So very clearly fake. And what you can do in most frameworks is most agentic frameworks, you just define a tool. It's just a Python function. And there's something called search. You take some keywords and you return some search results. Of course, in that body, we're calling Elasticsearch or doing some crazy re-ranking thing or calling some million-line code subsystem on the back end that's actually doing the intelligent search, right? And we pull back. I actually have a data set, just my blogs, and I pull those back. And now the agent can actually hopefully return some good results. And how this actually looks like, just to cut through all the BS, because there's so much BS about this, all you're really doing when you're doing agentic search is doing the same hello world call an LLM before, except instead of getting some hallucinated response back, you're already getting a request from OpenAI or whoever to call a bunch of tools on its behalf. And you can see what that looks like there. I've got some tools here with some arguments. It knows that there's a keywords parameter. It's actually searching for BM25, passing keywords to this tool called search. So it does this, and we just intercept that, and all the agentic tool calling loop is, it's nothing fancy. It's literally just a for loop after getting that and just basically dispatching a bunch of calls and sending them back. You go all the way back to the top because there's still tool calls happening, and you just keep appending that to the context that you're for OpenAI. And that's all you're doing when you're doing agentic search. It's just a bunch of for loops. You're just calling tools, getting results back, appending them, and handing them back to the agent. That's what an agent is. And it works. So on Esky, if you just sprinkle a little bit of agent on the data, you get pretty impressive results. You can see I've got some tool combinations here, E5 by itself, BM25 by itself, and an agent, and different model combinations. And of course, maybe not surprising, the best thing seems to be the best model, GPT-5, with BM25 and E5 as tools. So basically, in the last slide, I showed it giving search as a tool. I'm giving like one tool called BM25 and one tool called like search embeddings or something. And the agent's figuring out, oh, I need to call BM25 for this. I need to call the embeddings for maybe this more semantic thing. And it's able to like look at the results, think about them, and return finally, after calling a bunch of tools, a final ranked list of search results it thinks is optimum. And it can do a pretty good job at that. Not a perfect job, but a pretty good job. And even there's this really complicated data set called BrowseComp Plus that is basically this asking an agent giving an agent a corpus and asking it these questions that are extremely difficult, that it has to like search and get 25 different facts and check them against each other, and finally you get an answer at the end. And really, accuracy percentage is how many times the agent got the answer right. And you can see just BM25, just giving an agent BM25, actually doesn't perform that poorly. On these very hard tasks, it's like getting to 50 to 60%. So this stuff works, and it's very powerful. This is why people are excited about it. So, Autoresearch. So we can't agentify all the search yet. So all that stuff I just showed you is fun and interesting. And there are people working on smaller, faster, leaner agentic search models that maybe a couple years down the line, we won't have search backends. We'll just have one of these models taking queries as input and returning search results. That's the glorious future that maybe and maybe not will actually happen. So we can't do that quite yet. But what we can do is try to distill the lessons from that process into code that's going to rank our search results. And that's what I'm going to talk about today. So instead of having an agent take these two tools, we're going to say, hey, here's a bit of code. You can call this lexical BM25 function. You can call this embedding function. Maybe you could call this function to get a correction for your query or do some query understanding. And your job is to maximize some metric on this data set that you're seeing, that the coding agent sees. And yeah, that's what we're going to try to do. And so what does it look like? We start with some original source code. And it's always good when you're doing these auto research things is to work with relatively focused footprints. You're not like trying to optimize a 500,000 line code base where the agent can potentially touch anything. It's often better to be really focused on the decision space. So we're going to start with this like function. It's called rerank wands. So wands is the Wayfair annotated data set. It's just a furniture and home goods data set, e-commerce data set. And I have found that roughly these BM25 parameters of boosting title by 9.3 and description by 4.1 tends to work best as a BM25 baseline. And we write that out, and we're going to ask an agent to improve the relevance of this function. And how this actually works is our agentic loop just looks differently. We have a training set. So training set is just our judgments. It's a bunch of queries. It's documents and whether or not they're relevant for that query. So document 1, 2, 3, 4 is relevant. For red shoe, 5, 6, 7, 8 is not relevant. And the agent has access to that. The agent's going to hypothesize some changes. It's going to edit the code. And then there's going to be some eval tooling that basically gives you for each training query what the NDCG delta of after the code change was applied. So this code change came in, it just comes in as a patch, and we apply it, and NDCG for some queries goes up and some queries goes down. And then the agent sort of thinks about that and says, maybe I should try to fix for these cases that got worse and try to preserve some of the things that got better. So it's trying to optimize and improve all the queries as much as possible. So you can do this yourself. Of course, there's things like Goal in Claude and Codex and these kinds of things. It's actually not that hard to build your own coding agent. All you need to do is have a tool. This is a tool, apply patch. It's going to try to save the patch. That says rerank esky. That's a typo. It should be wands. It's going to apply the patch, and it's going to give us a response, which is basically like the evals of what happened when we applied the patch. And all the patches is a search and replace. So it's like anchor is the start, block until is the stop, and then some action is what to do. And I'm left off the fourth thing, which is the text. So there is some text that you might you search for the start, find the stop, and just like rip that out. And there's a text parameter that got cut off that might plop into that location. So it's not that hard to build your own coding model. And that's why you see people doing you see all kinds of coding agents cropping up these days because it's actually not that difficult. Yeah, this is just showing you, it's just doing a search and replace with that text. If you do insert after or replace, it's just pretty straightforward to do. And when we run the evals, like I said, we get these NDCGs back that are just deltas for how things improved or didn't improve. And I'm not using Goal like you can in Claude Code, but one thing to keep in mind with all of this stuff, you always have to be really careful about what the agent has visibility into, because the agent can really easily cheat on a lot of things. I'll talk about that in a minute. But you can use Goal, you can use Claude Code, you can use Codex, but you probably need to do a lot of instrumentation within that agentic framework to do the right amount of data hiding and data visibility to make sure it's not doing things. But I like to have my own thing to dork around with for experimentation. And so you can see the tools like before. These are the same kind of concept. We give an agent a tool. In this case, we're giving an agent a tool to interact with its environment in a code editing capacity. It can apply changes, revert changes. It can actually do things like just search the data set directly with a more primitive tool. It can run the re-ranker on a single query just to see what a single query does, and it can run the evals by itself just to get some stuff back. And I just, setting all that stuff up, I actually just now, once I have that set up, I more or less now just, this is just some YAML that tells how I configure these things. You can see it's basically just summarizing what I mentioned. The important things are the search tools, again, some kind of BM25, and an embedding E5 base v2. I indicate the training queries. I'm going to use 20% of the queries for training and some seeds and things, and then a system prompt. Yeah, these are just the tools I'm using to actually, that the coding agent can call to get results and manipulate them. The system prompt, just kind of giving some hints about tools and the task and what to do. And yeah, and we also append the starting code to the system prompt. So you can see here where the fielded BM25 and E5 base v2, those are just injected, they're passed in. And then the query itself, that's just your like red shoes or whatever. And the agent's job is to create a function that looks just like this and tries to optimize relevance. So it's going to probe around and try to do these things. And again, this is just the same tool calling loop. There's nothing fancy about this. You can write this code and make it work pretty well. Yeah, or just pretty picture form. And so we do this once, and we get a function back. And it will give us this nice, beautifully commented doc string in Python. This is all Python. And once we get this back, we can start the process again. We've gone through and done one set of that tool calling loop, and the agent exited saying, I optimized something or I didn't. But we can also just like take the code from a previous round and say, this is our start code now, optimize this to make this a bit better. So we do that so that we can do rounds and rounds of these auto research runs. And that's when you do /goal in coding agent, that's also what it's doing. And I will do this over, say, 10 rounds. And when I do this over 10 rounds, what's interesting is you see these, the LLM labels the changes themselves, so sometimes they're a bit weird, like NDCG plus 0.0013. But you can see some of the things it did. It figured out how to do a hybrid re-ranker, boost and expansion, some phrase stuff with colors, who knows. It looks pretty good. Looks like its NDCG went up from 0.54, where the BM25 baseline is, to like 0.575-ish or something. Unfortunately, when you look at the code, and this is a thing that happens like every time I teach my course on agentic search, someone goes and says, I'm just gonna put this into Claude and I'm gonna be really smart and it's gonna optimize it. But you get this like crazy suspicious looking code that comes out. And speaking of search management, this is like your search management's worst nightmare, because it's all these very specific things targeting when a rug occurs or rugs occurs. We will rank things a specific way. And to me, this looks very overfit. It looks like it's tailored to the 480 queries that are in this data set. And yeah, the other problem is this, look how long, now we're 404 lines long. So it's a very long, complicated function that's gnarly. When you look beyond the training data, it also looks a bit messy. It's a bit all over the place in terms of some things got better, some things got worse, and it just starts to feel like something that's maybe overfit. Or only overfit, for those who don't know, just means it will only work on the training data. It won't work if we put this into production on anything outside that 480 queries. So we can do things just like we do with machine learning. I add this idea of a guard this is similar to the idea, if you've worked a coding agent, of a hook. But this is something preventing a change from being applied. So I have a specific validation set, and the agent can only see the overall change in NDCG of validation. It can't see query-specific validation. So it sees that the validation NDCG went up or down overall, like the mean of all the queries, whereas the training data, it sees the, like, oh, red shoes went up and blue shoes went down. You can also have just a check. I have a check that just calls out to GPT-5.1 and says, does this look overfit? And it can reject it for that reason. So all of these are preventive checks to say, don't save this code if these fail, and you'll get the agent gets a nice error message. So instead of the agent getting some like happy message about what NDCG's changed, that message, the agent gets back this failed because you didn't improve validation at all. Those kinds of things. Yeah, and all this is before we apply patch, we reject the code. The other thing I do is shrink the decision space. This is very important for auto research. If you want an agent to understand cause and effect, you don't want it to it's very hard to link a 500-line code change to a specific query going up and down. It's much easier, and think about how we as humans tune search. We maybe see a problem, and we're like, oh, long queries we don't seem to be doing well with. Let me go change a few lines here in this search API or this query. Then we can see if that improves things. So we sort of force the agent to do more targeted, smaller changes in each of its edits. So that basically, if the agent proposes a patch that's larger than this size, the agent will reject it and give an error back to the agent. So now we have auto research with validation, proposing patches, and failing. And the other thing I found that was useful is to give the agent a tool that only sort of tries the patch out only on training data and just evaluates it on training data. So this is trying to do a permanent save, and this is trying to do it as a temporary thing. Yeah, so I found this process worked really well. You kind of had a softer experimentation phase followed by the actual, these actually have slightly different names, but I actually prefer the name commit patch as that last step. This is actually trying to do a commit that's actually running validation. But because to give it sort of a sense of how, like playing around with ideas more without having to go through that validation check, I give it a softer tool to run experiments in scratch code. And we get a much higher plateau when we do this. So we start doing you can see it's doing a lot of RRF kinds of fusion, some title weight changes. Eventually it gets some kind of consensus with RRF and does some interesting stuff. And actually 0.54 to 0.59 is a nice little experimentation change on this data set. The problem, and this is just another agents cheat all the time, is our final code looks like this. And remember I said I'm limiting to 120 columns, 10 lines, and it's like, well, that means I have to be as compact as possible. And so you get this weird minified code. Luckily, you can paste this into ChatGPT and it'll explain it to you, and it sort of says it's doing some BM25 search, it's played with the parameters there, it's weighted title a bit better, it's doing some kind of weighed RRF, and there's some kind of bonus in the RRF for it coming from both places. So it's like a little slightly different RRF. RRF, for those who don't know, is just a way of combining vector and embedding search, which it's using as its core retrieval primitives. So I think one big takeaway from all this is LLMs really pick unsurprising solutions. Remember, these are LLMs. LLMs are basically the encoding of the encyclopedic knowledge of all human language. So they're going to pick the things, like if it has a vector search tool and a lexical search tool, it's going to say, hey, I think I know how to do this. We use reciprocal rank fusion for these things because that's what 100,000 people have written blog posts about for doing hybrid search. So it's an interesting thing to think about as a constraint with this, is we're really picking things that are well known and not necessarily innovative. And the thought about this, that the next step in this is, what if we give the agent even more? It's fun when you do this with like an embedding tool and a lexical tool. What if we give the agent just tons of things it can play with when it's constructing this auto research ranking code? Well, if we give too many things to the agent, well, just like machine learning, this is like a curse of dimensionality problem. It's just way too much to play around with. Or we could give something more open-ended. So these are very targeted tools, a bit more targeted tools. Rewriting queries, getting commute distance, categorizing queries, like these are very targeted. Or we could give something more open-ended. But the big thing is there is a big curse of dimensionality here. So if we give an agent many things to try, in any context really, it will waste all of its context exploring the possibilities. There can be things in here that the agent has, there can be things in here that maybe we can do tricks to help guide the agent, to help it remember what are good ways of operating in this data set. But that's going to use context too. And if we enumerate all of those things, that's going to take a lot of context. So when you work with an agent, you're always thinking about, just like machine learning, there is a curse of dimensionality problem. One approach to solve that I have found to be really useful is to do a bit of data hiding. So this search here, so what I could do is take from a previous run, the thing that I got up to like 0.59 NDCG, that takes a lexical search and an embedding search. And I could just pass that into another auto research loop as a dependency and give it one more thing to add onto that. So it's not trying to optimize a larger space. It's just taking this initial retrieval pass, but then adding onto it, oh, I can also rewrite a query. And rewrite query, I think, is just an LLM prompt to spell check a query. And yeah, so we basically, to the auto research loop now, we have two kinds of tools. We have this one that was learned last time, and we're just going to call it search, and we're going to inject it. And then this new thing called query rewrite. And that's interesting because if we train with the rewrite, I think this gets a little bit higher than what we had before. Oh yeah, so if we train with if we just add all of these tools together, actually we get a little bit worse than we had before. So if I don't do this amount of data hiding, and I just give it a rewrite tool, an embedding tool, and a lexical tool, I actually get slightly worse results. And then if I do all together, I get this much better results, where there is already a baseline start there, where that is the last time I ran, and that's just that original search code is basically frozen. And now we're just optimizing on top of that with this query rewrite and also some other things that it's doing to maybe just look at the query string a bit better and do things with it. So I thought that was really interesting. It's like when you hide information from the agent, it actually can do a better job of optimizing. Yeah. So I just want to close. I'm not going to walk through this too much with a experiment I ran where I said, could I make a better BM25? And I actually I have a blog post on all my stuff, softwaredoug.com. I have a blog post that talks about this. You know, BM25 is well-known lexical ranking solution. Can we make it better? Can we auto-research it better? And I gave it some code that gave it this like really raw implementation of BM25. And I said, you know, see if you can improve the ranking of this. And I'm going to skip ahead because I don't have a ton of time. But just as an experiment, I ran this for a bit. I did a mini Marco experiment. Mini Marco is just a smaller MS Marco. Seemed to get better. Unfortunately, when you extrapolate from this tiny data set to a much larger data set, tends to plateau around 0.19-ish. So the regular BM25 starts at 0.18, and we get we flatten out a little bit. So this is like a classic question answering data set, and it tends to plateau So one thing that is interesting about this, and I'll just leave this as kind of like a final bit of caution, even your validation data, when you're doing this kind of work, you can overfit to it. Because I was working in a smaller sampled set called Mini Marco that just and it started to find things that it considered stop words that were not technically overfit to that Mini Marco data set. So they still improve validation, but they were like random things like medicine and vacation. So very specific terms, these can be stop words that only matter to the smaller sampled data set I was working with. So still some interesting results. It's interesting to see how BM25 does some like bigram boosting and this kind of thing. I thought that was interesting. And then Vespa, I want to shout out Vespa. Of course, I think there's a couple of Vespa people. Took this even further for this question answering data set and said, can we get even deeper? So they show starting from my result of like 0.19 something, they get to about 0.2106 just using different Vespa features, which have more things like term approximation and whatnot. I'm still doing this for e-commerce. I'm trying to find a better BM25 than just sort of like what I started with. I'm not quite convinced I'm there yet, some fishy data, but that's kind of where I'm at right now. So yeah, this isn't magic. I think it's more data-driven collaboration. You kind of have to keep an eye on things. And I like to think about it as similar to how people are solving Erdos problems now. A lot of this is actually really keeping up with the millions of search traces, or not search, but traces through solving math problems, and noticing when one of those traces actually seems to produce interesting results. That's how Erdos problems are a very difficult math problem, and you're seeing agents sort of like go around solving those now. And they're really, in many ways, they're finding prior art. That's really what they're doing. They're finding prior art and applying them in novel ways to problems. And I think we're kind of seeing the same thing when we do auto research. We're finding prior art and we're applying them to these problems. So yeah, with that all done. Thank you so much.
Time for questions.
Thank you, Doug, for the talk. I know this is not the focus of the talk, but do you have any sense of how the increase in mean NDCG meant in terms of latency, consume of energy, I guess, and money?
Yeah, that's a great question. That's not something I was directly measuring, but I think you could measure that. I think a lot of this auto research stuff, and honestly AI coding in general, it's about expressing these kinds of constraints as much as possible about latency. And yeah, I wasn't looking at that specifically, but yeah, so I think it's a good point.
Then I'll ask a question.
Yeah, go for it.
So how to force an agent to do something novel? So usually it tries just to the most reasonable thing, like RRF for fusing results, but that's kind of the obvious thing, how to push it to do something non-obvious.
Yeah, I think there's two things. One thing is you can give it the ability to search the web for solutions. So it's one thing that you see people do with auto research. The other thing is like literally tell it to give it some hypotheses to try. So I think a lot of these things are better done collaboratively right now. But I think like explicitly giving hypotheses is probably the best thing. I'm not sure you're gonna see, I have seen a bit better results with higher levels of reasoning, but still, it's not like crazy, novel, creative things out of complete left field.
Thanks. You mean collaborating between agents and humans, or between agents?
Well, maybe both, but I meant more agents and humans.
Oh, one more question.
Thank you. How do you ensure that the agent is exploring the good part of the solution space?
You said the good part of solution space?
Yes, there is many possible solutions, and if I do a parallel with machine learning, the agent may be aware of the gradients.
Yeah, you can get stuck in a local, I shouldn't keep wandering away. You can get stuck in a local optimum. 100%, that is a problem. I am curious if if there are semi-genetic approaches to this, because you can imagine different variants running, different auto research variants, and then you want to take like A and B and get sort of their offspring and pick the best of each. I haven't messed with that directly myself, but that could be interesting.
Just very quickly, do you remember Querite, the genetic algorithm thing that Tim Allison did? That and an agent might be an interesting place to go.
That's true, yeah. That was all based on genetic work. Okay.
So we probably need to have a special tool for LLM called Ask Doug.
Yes. All right. Thank you all so much.
Thank you.